Hi there, algebra students. Mr. Rising here. And in this performance assessment, a test, is all about working with exponential functions. The point of this is to see how exponential data lives in the world all around us and how you can make sense of it and make predictions. So what I want you to do here is I'm going to walk through the instructions and then actually show you how to do it in Google Sheets, because this is a powerful tool. If you don't want to do the Google Sheet route, you can do it by hand, but you'll need a calculator. So what I want you to do is find an exponential growth or decay data set. Pick something that you're interested in and get real data. And I'll show you how I'm going to do that here. You need 10 data points or more. And I have a list of examples of types of things. Don't use my CS example. You can pick something else to work on. Then we're going to use a spreadsheet to make a scatter plot. And then part 3, we're going to build an exponential function from the real data. And then 4, you're going to plot your function compared to the real data. 5, we're going to use it to predict the future value. And then 6, we can have a little comparison of how our model modeled the real situation. So in this case, my data set I'm thinking about is Arctic sea ice. So I went to the Arctic National Snow and Ice Data Center. This is part of NOAA. So it's a great place to get data. Government agencies are great places to get data, regardless of your topic, forestry health. I mean, look at the examples. So what I did was I went down and I found the maximum ice extent spreadsheet, and it actually pulled it up right here in a file like this. So I'm just going to kind of leave this on the side of the screen. And you can see this is the data that I downloaded. It has the maximum ice extent for every year. Basically, I'm going to plot that. So what I need to do is get this data, and you might be working from a screen. Like, all right, here's my data. How do I put it in there? Well, let's start by making a Google spreadsheet. So I'm in my Drive. I like to keep my world organized. All my Algebra files are together. And I go over here to New, and I go New Sheet. Yep, create and share. Now, of course, you want to share it with me, so when you submit it on Canvas, I can actually see what you're doing. You just go click up here and share, and you type, you got to name your spreadsheet first, so this is going to be like Rising's Sea Ice. Okay, and again, I'm just going through, and then my name again here is George.Scriba. There I am, and you can let me edit it or make comments or whatever, that's just fine. Send a little notification. That doesn't mean it's submitted. It just means that when you submit it through Canvas as an uploaded file, I can look at it right away. Okay, so what I need to do, I'm back here. I need to get this data entered in. And that's like 40 data points. It's probably more than I need. Well, actually, I'm just going to do it every 5 years and kind of keep it simple. And since I've been using spreadsheets since I was in high school, I mean, number one, I could copy this down. I could type in, let me just close this up a little bit. See what I'm talking about. There we go. I could type in year and then, 1979, right? But I also can use the copy and paste function, and I'm a big fan of copy and paste. So I'm going to just grab my data. Oh, escape. Grab my data. And I'm going to go copy paste. And you'll notice here that the years were like 1979, 84, 99, etc. every 5 years. What's really important when you work with time is that in exponential functions and data sets is really the first year of data. Your starting point is year 0. So that's why I have a column here called year 0. It's like, well, this is year 0. And then I just, I added 5 to each one. You can also do that with a function, however you want to do it. You might be adding 1 to every year. Not a big deal. And then this is the data. So basically, I could have copied this in, typed it up by hand, or I could have worked it that way. Now, let me just go back and answer my questions. All right, I've got my data points. I need to make a scatter plot, okay? Make sure I label it correctly, and then I'm going to eventually build an exponential function. So let's make my scatter plot first. I go right here. Now, basically, from this point forward, I'm going to ignore the true year, and I'm just going to focus on the year since the start. So I'm going to look at this data, and I'm going to go to Insert, and I'm going to do a chart. And that chart, when it loads, I want it to be a scatter plot. Let's see, I'm going to scroll down here. There's a scatter plot. Bam. And what's really cool is if you put your labels in the top row, it's called a header row. It's like, oh, you mean the year 0 is the x-axis, and the maximum extent of the sea ice is the y-axis. Pretty cool. It basically builds it for you. And you can see it's going down slightly. And I'm curious, I think it's actually going down exponentially, just a little bit. And if I'm wrong, that's okay. It also gives you a title right off the bat, which is really helpful. Fair enough. I'm going to call that good. All right, I've now made a scatter plot. Spreadsheets are cool. The next part of this is actually building the equation. And it says starting, remember the form is f of x or y equals ab to the x, where in this case the variable is the exponent. Starting value is a, and then in exponential growth, you need to find the percent change that occurs. And how you do that is the new value minus the previous value divided by the previous value. Here's what I'm talking about. I'm going to call this percent change. So the first one, I can't compare it to the previous one because it's the first one. The second one, what I'm doing, and notice if you're going to do it this way, I'm going to put in parentheses the 1984 sea ice minus the 1979 sea ice, close parentheses, divided by the 1979 sea ice. That literally means new minus original divided by original. That's how you find a percent change. And the percent change was negative 0.049, almost a 5% loss in sea ice between 1979 and 1984. Now, I could type that in again. I could do, okay, all right, parentheses, this minus this divided by that. And then this year is like practically 0% change. It really didn't change much at all. I can also take this formula and I can copy it, and I'm holding down the shift key, and I can paste it to all my points. So now I've just figured out the percent change every year. Many things in nature aren't perfect, right? They go up and down, they change, but there's a general pattern that's going on. In fact, when I go back to my data here, you might be kind of curious about this. There is a downward trend, and that's what really caught my ice in the first place, or my eyes in the first place. Anyway, I meant to show you that too, but basically sea ice has been going down for the past 4 years, and I'm curious if there's an exponential trend to it. All right, get back to work here, Mr. Horizon. Come on. All right, so polar sunrise, where is it? There it is. Here's the picture. Sorry, I had to show you. Basically, this is this maximum sea ice every year, and you can see it's a downward trend. They put a linear model. I'm going to see if an exponential model fits. All right, before I get too far away, find the percent change. Now, I'm going to average it. How do you find an average? Well, you take all the numbers, right? And I'm going to take this in here as, move this out of the way just a little bit. All right, and we're going to call this average. Average. And then the command in Excel is average. Average. Equals average. And it's suggesting, like, I think you want to average those cells. That's fine. Or you could type it in equals average parentheses D2 to D10. I don't need to put in the header row. And actually, I don't even need to have D2 in there. I should really be starting with D3. So it's basically saying, I just figured out the average percent change every year was 1.3% decay. It's going down every year. I'm trying to speed up here. I know it takes a while. B is the growth and decay factor found by taking 1 plus or minus the average percent change. Okay, so let's build my function. So here's my equation. It's going to be y equals my starting value, which is 16.635 times 1 plus a negative, or 1 minus, minus 0.0137 to the t, or the x, to the years. So I've just now built my equation. Cool. All right, going back to my instructions, plot your model by plugging in the x value into your function. Okay, so here's the fun part. prediction. So what I'm going to do is I'm going to use my equation on the number of years. So watch, I'm going to go equals 16.635 times, parentheses, 1 plus this value. Now watch, I'm going to hit the F4 key. I'm going to put dollar signs around it. And the reason I'm going to do that is as I copy and paste my formula down, I want to keep using the same average number, right? Close parentheses, to the power. On a keyboard, it's Shift Fix. And then the year is that one right there. Sweet. Again, I'm using my starting value, and that makes sense. I'm predicting the exact thing. Now I'm going to copy this. Now you notice I can actually grab the little corner here too and go. But make sure your numbers make sense. Make sure that what you're doing here is like, wait a minute. Oh yeah, that's right. I'm using the average, my starting point. Okay. Yeah, cool. All right. Fair enough. Back to my instructions. Let me get this out of the way. Plot it. So I need to plot it, and then I can predict the future value, and then how well does it work? All right. So let's do year 100. I'll predict that one as well. Okay, they're saying in 100 years you'd only expect 0.1 thousand square miles of ice or kilometers of square ice. All right, now what I want to do here is change my graph to include the data. If I click on the graph, I'm going to do series. I'm going to add, I need to add another series to it. Here we go. Let's see if it'll let me do this with series, max extent. Oh, I gotta find it. There we go. Add a series. And then here we're gonna do prediction. Basically, that's what I'm gonna do here. I'm gonna go to series, setup. Sorry for the delay there. Select data range. E1 colon E11. Okay. There you go. So I just added a new one. Of course, that's my predicted value. How well does this work? Well, you can see my red line is going down. It almost looks linear, but actually that's exponential. And the blue line kind of goes up and down a little bit. So I would say my exponential model is not a really good fit compared to the linear one. I hope this helps. Again, you can go back and watch it again. Let me close my screen there. But let's just make sure I answered the questions. Okay, I have my data points. I've got a topic I'm interested in. I made a scatter plot. I built an exponential function. How well does it predict? Okay, did that. Yeah, it doesn't predict very well. I hope this is helpful. Please let me know. Put discussion questions into the discussion topic specifically and try to help each other out. And look forward to seeing you in class.